All right, so let's pull back the curtain on something we use every single day: technology. We're talking about how an app on your phone or some complex piece of software actually gets made. We're going to go from that very first spark of an idea all the way to the finished product. Okay, let's just dive right in.
I mean, you've probably wondered this, right? It can feel a little bit like magic. But the truth is, behind every single piece of software, there's a really structured process. It's a journey, really, from a blueprint to a final building. And that's the exact journey we're going on today. So, before we can even think about building anything, we have to understand the basic material we're working with. And in the world of tech, that foundation is the whole concept of a system. So, what in the world is it? You can think of it like a perfectly designed machine, or maybe a really complex puzzle. It's not just a random pile of parts. It's a bunch of components that are specifically picked out and linked together to do one specific thing, and to do it really, really well. Now, systems are often defined by how much they talk to the world around them. An open system is kind of like our respiratory system. It has to take in stuff from the outside to work. You know, like how an e-commerce site needs customer orders to function. A closed system, on the other hand, is more self-contained, a lot like our circulatory system. And look, getting this difference is absolutely crucial because it tells you how to design the thing. Do you need to connect it to the world or protect it from it? All right, so we get the basic idea. Now, imagine you're a builder for a second. You wouldn't use a sledgehammer for every single job, would you? Of course not. You need a whole toolkit. Well, it's the exact same thing with systems. You've got to pick the right type of tool for the job at hand. And here are just a few of those specialized tools. You've got your transaction processing system, or TPS. That's the workhorse for all the daily stuff. Think of an ATM processing a withdrawal. Then you've got the Management Information System, or MIS, which helps managers plan things out by summarizing all that data. And finally, you have the Decision Support System, or DSS, which is the heavy-duty tool that executives use to model complex problems and make those big strategic decisions. Okay, so we've got our concept, we've picked our tool from the toolkit. Now we get to the most important part, the blueprint. This is the plan, the methodology that's going to guide the whole construction process from start to finish. And this is such a critical question. Seriously, the blueprint you pick is going to determine how fast you build, how you deal with surprises along the way, and what that final product is actually going to look like. It is definitely not a one-size-fits-all kind of deal. You basically have two main philosophies here. On one side, you've got waterfall. It's very linear, very rigid. You finish one step completely before you even think about moving to the next. It's great if you know exactly what you need from day one. But on the other side, you've got agile, which is all about being flexible and working in cycles. You build in these small little chunks and you're constantly adapting. It's pretty much perfect for projects where you know things are going to change. But what if you need both? You know, some structure, but also some flexibility. Well, that's where a hybrid approach, like the spiral model, comes into play. It kind of takes the clear stages from waterfall and mashes them up with the repeating cycles of agile. This is the go-to for really big, high-risk projects because it lets teams build and test little prototypes in each cycle so they can handle any uncertainty before it blows up into a huge problem. And speaking of prototypes, there's another model that's all about feedback. It's called prototyping, and its whole philosophy is show, don't just tell. The idea is a really simple loop. You build a basic working model, you put it in front of users, you get the reactions, and then you revise it. You just keep repeating that cycle until the prototype becomes exactly what the users want and need. It's an amazing way to make sure the final thing is actually easy to use. Okay, we've got our blueprint. It's time to break ground. We are moving from the planning phase into the actual construction, which follows this really structured set of stages known as the System Development Lifecycle, or SDLC for short. Now, one really structured way to manage all this construction is with a methodology like SSADM. And as you can see from these stages, it follows a very strict, very logical path. You start with a feasibility study, just to see if the project is even possible. Then you move into detailed analysis and specification, before you create a logical design, and finally, a physical one. Every single step builds on the one before it. And that first step, it just might be the most important one of them all. Before anyone writes a single line of code, before a single dollar is really spent on development, the feasibility study asks the really tough questions to see if the project is practical, if it's beneficial, and if it's even worth doing in the first place. So what's it actually looking at? Well, it really boils down to three main questions. First, technical. Do we even have the technology and the skills to pull this off? Second, economic. Is this thing going to provide more value than it cost us? And third, operational. Once we build it, are people actually going to be able and willing to use it? If the answer to any of those is no, it's time to go back to the drawing board. Once a project gets the green light, analysts have to become sort of like detectives. They need to map out the whole process to understand it inside and out. And one of their favorite tools for this is the data flow diagram. It's basically just a visual map of how information moves through the system. A DFD has just 4 simple little parts, but together they tell a really powerful story. You've got external entities. Those are the people or other systems sending and receiving data. You have data flows, which are the roads the data travels on. Processes are the things that actually change the data, and data stores are, well, where the data is kept. It gives you a complete picture of how the whole system works.
Okay, let's fast forward a bit. We've gone through all the development, this system is built, it's been tested, but the job is not over yet. Now comes the grand opening, the deployment, and how you launch your new system is a huge strategic decision all by itself. As you can see here, you've got several options, and each one has its own trade-offs. You could go direct. Just flip the switch, turn off the old one, turn on the new one. It's fast, it's cheap, but man, is it high risk if something goes wrong. The total opposite is parallel, where you run both the old and new systems at the same time. It's super low risk, but it can be slow and really expensive. Phased and pilot are kind of a happy medium, letting you roll out the system bit by bit, balancing that speed, cost, and risk. So after understanding this entire complex journey, from a simple idea to analysis, design, and deployment, every single organization has to face one last fundamental question. Do we go through all this trouble ourselves, or is there maybe an easier way? And that final choice really comes down to this. Do you buy or do you build? You can buy what's called a commercial off-the-shelf product, or COTS. It's way faster, usually cheaper, and it's pretty much ready to go. The other option is to build a completely custom solution. Now, this takes a lot more time and money, but you end up with a system that is a perfect fit for what you need. And that can be a real competitive advantage. And that really is the heart of it, isn't it? The question just boils down to this. Are you going to change how you do business to fit the tool, or are you going to build a tool that fits your business? The answer to that question determines everything. So the next time you have that spark, that idea for a new app or some piece of software, you'll know the incredible journey it has to take. And you can ask yourself that fundamental question. Are you a builder or are you a buyer? The answer is going to shape everything that comes next. Thanks so much for watching.